So we're going to look at the very last section, and if you'd like to follow things in the book, notice that in this chapter we're only looking at the titrations, and you guys have kind of already done this in lab. Here's Dr. Bean's video on this. I'll include it in the playlist. And a titration is a specific way to do an acid-base reaction. The reaction occurs in here. It occurs in the flask. So everything discussed in the chapter applies to this reaction. So everything up to this point, it's all the same. But this is to point out that instead of starting with a mass, because the examples so far have started with a gram amount, instead of starting with that, you could also start with a volume and a molarity. So this is bringing chapter 6 into this part of the video. Here's some more information. This may be especially helpful as you're looking at the Newton homework. So there's more information right there. And we've got another one of those visual summaries of the math right here. It's just another one of those pictures with the squares and the arrows. The last bit of this practice problem we're going to do right here. All of these have a reaction just like we had before. So there's your reaction. And it says the end point of a titration. So this just means that the reaction is done. End point means the reaction is done. It means that this has happened. And what we have is 50.0 milliliters of the HCl. And we have 35.23 milliliters of the NaOH. And it's telling me that the molarity of the NaOH is 0.050 molarity. We want to know what's the molarity of the HCl that had to be used to make this reaction happen. So we're pulling together several different ideas. By the way, if you like the idea of writing amounts under a reaction, that's totally fine, and that really works well for some people. That's what I've done here, is write these amounts under here. And this may even feel like a dilution problem, but it's not. It's actually doing a reaction. We're going to take... You need to start with something that has a single unit. So that means we're either going to start with him or we're going to start with him. What does the problem say it wants us to find? It wants us to end with HCl. That means don't start with him, because that's what they want him to end with. So what you want to find is the molarity of HCl. So don't start with him. Start here with him. So we're going to take 35.23 milliliters of HCl. We're going to go from milliliters of HCl to liters, because if you remember, we can put that this is the same thing as moles in a liter. I put the number in correctly, but that should say 35.25 milliliters of NaOH. And then on the bottom of the next section should say milliliters of NaOH in a liter of NaOH. I fix it on the third one, so that's liters of NaOH and then 0.250 moles of NaOH. You'll see this corrected on the key. Just make sure you say NaOH up until this point, because now we're switching to HCl. Apologize for the confusion. 2 is molarity of HCl. So moles of NaOH into moles of HCl. Looks like it's 1 to 1. So this is going to get me moles of HCl, but that's only the top part. And I need it to be it looks like I've got 1, 2, 3 sig figs in the middle. So I need 3 sig figs, 0.00881 moles of HCl. So this answer is in moles of HCl, but the question is asking for molarity, and that's why the milliliters matters. So I need to turn the milliliters into liters so that I can use my molarity equation, which is moles divided by liters. You'll see in a second that liters is going to be 0.0500. I left a 0 off. The denominator is the 50 milliliters converted into liters. 0.1762 molarity of HCl. I need it to be to 3 sig figs. Because of my 0.00881 moles of HCl had 3 sig figs, which came from the moles of NaOH. And yes, I know it also feels like a dilution problem where you could do MV equals MV. That only works if the reactants are 1 to 1, which they are here. But if you look at this reaction, do you see here? It's 1 to 2. It's not going to work. It only works when it's 1 to 1. So this next problem has all of the same numbers. The only thing that's different is that there's a 2 in front of the NaOH. I meant to circle the lower number, the one beside NaOH. That will be a 2. So go ahead and pause the video and work this problem. So the molarity of the H2SO4 is, and again, it wants me to find that molarity, so I don't want to start with him. I want to end with him. So, and some people might just go ahead and say, why don't you go ahead and turn that into liters? You could. So I'm going to go ahead and show this one already turned into liters. Now I don't have to do this step that's right here. And then, remember, this is the same thing as saying moles in 1 liter. And you should always say what you're talking about. So liters of NaOH, liters of NaOH in moles of NaOH. Now I'm going to go from moles of NaOH into moles of H2SO4. And so this is 1 to 2. So I'm going to write down 0.004, but I should have put it with 3 sig figs because of the 0.250 moles of NaOH. You'll see me correct it in a minute. And if I want to know what the molarity is, then I say my 0.004 moles. Oh, and by the way, I should have left that to 3 sig figs. So it's actually 0.00441 moles of H2SO4. 0.001 moles, 441 moles of H2SO4 divided by the liters. And it was 50 milliliters, so if I put it as liters, I get this number. So divided by 0.0500. 0.0881 molarity of H2SO4. And that's my answer for the second problem. You can go ahead and work the third problem. I'll have that on the answer key online. And then these are some general practice problems just to make sure that you get everything on the chapter. It's kind of a mix of easy and hard. And that walks you through this chapter. I know it's a lot of math, and it feels a lot of math in the last video part. The best you can do is practice it and maybe have an example, kind of like I have on this page up here, like where you have it in your head so that you can see the picture in your head of what this looks like. And just work every problem the same way, following the same method, and you'll do just fine. That's a wrap for Chapter 7. Yes!